Section 4.3, Logarithmic Functions, Part 4. Find the domain of the function. Okay, so let's think about domain. When we think about domain, we want to think about the values of x that we can plug into a function. Okay, so here let's come back and review a little bit of what we know regarding graphs of logarithmic functions. Okay, so we have logarithmic functions and exponential functions being inverses of one another. That means their graphs reflect on the line y is equal to x. If I have a point 0, 1, then in its inverse we have switching the x and y positions 1, 0. For our exponential function, we'll consider the one that increases, a to the x. If we were to flip these across the x-axis, the x-axis asymptote would become the y-axis asymptote, and then we'd have a graph that looks like this for log base a of x. Okay, so what we want to do is we want to know the shape of the logarithmic function base a, and that's what we see here in pink. The y-axis is the vertical asymptote. The equation of the y-axis is x equals 0. Okay, when we look at domain of the logarithmic function, those are your x values. Notice that x will never touch or cross 0, but go to infinity. So there's our domain. It won't touch or cross 0, but then goes to infinity. Okay, how about our y values? Notice y starts here at negative infinity. This does increase forever. It's just slow. It's going to end up at positive infinity. And so that's the range of our base graph. Okay, so in our two problems that we're working here, we're looking for the domain of the function. Any logarithmic function, the domain is going to always be whatever we're logarithming, set it greater than 0, and there's your domain. Okay, so we would take negative 2x greater than negative 8. We are going to divide both sides by negative 2, which reverses the direction of our inequality. We end up with x less than 4. And so there's our domain, negative infinity, but not including 4. If you're working with a logarithm, whatever you're taking the logarithm of, set it greater than 0 and solve. Okay, here's what we're taking the logarithm of, x minus x squared. So if I want the domain, I just set that greater than 0. Okay, so let's see. I'm going to add x squared to both sides. Adding or subtracting doesn't flip any signs. It's only multiplying and dividing. I'm going to add x squared to both sides, and then I'm going to go ahead and subtract x. I'm going to subtract x. So we have x times x minus 1, a graph of a parabola that opens up, crosses at 0, crosses at 1. What we want to know is when is this graph smaller than 0? When is this graph smaller than 0? When is it below the y-axis. That would be here in between 0 and 1. So that's its domain, 0 to 1. Now this part especially we have not seen in a while, so you might want to go back and look at polynomial inequalities. This is a polynomial inequality. Okay, sketch the graph of the function by plotting points. Okay, so let's go ahead and we're going to graph the function. So we're going to go ahead and get a nice set of xy axes. We're going to plot points. So that means we're going to pick x's to give us our y's. We'll get those points and plot. Now, thinking of log base 4 of x, we want to think of what we want to put in here for x. For example, I don't want to put 5 because then I'm stuck. I really can't go too much further from here. But what if we plug in numbers like 4? That's going to give us 1. What if we plug in numbers like 16, 4 squared? That's going to give us 2. Notice that numbers that I want to pick to plug in are going to be base 4. So that way we can get these to cancel, since logs and exponentials are inverse functions. Okay, so my usual here is 4 to the negative 1. That's what I'm going to plug in. 4 to the 0, 4 to the first, and we probably don't need 4 squared, but let's just go ahead and list it just in case. Get rid of all that scratch work. We're just kind of thinking of different ideas on how we can, or what numbers are good numbers to plug in for y. Okay, so each of these x's are going to be plugged into log base 4 of x. So if I want y, we're going to take log base 4. Let's go ahead and plug this x in, 4 to the negative 1. And what does that equal? Log 4, 4 cancel. That equals 1. So we're going to be plotting the point 1/4 negative 1. This is the equivalent to 1/4 with that negative in the exponent. Okay, so let's look at log base 4. Now we need an x to plug in. The x that we're plugging in is 4 to the 0, and we get 0. So 1, 0 would be the point that we're plotting. 4 to the 0 is 1, and then the y coordinate turned out to be 0. Okay, y equals log base 4 of 4 to the first. Cancel those out. So here we'll be plotting 4, 1, and then y equals log base 4, 4 squared. Those cancel out. And so 4 squared is 16. We would be plotting 2. Okay, so at 1/4, we're down here at negative 1. At 1, we're here at 0. 2, 3, 4. We're up to 1. And we want to remember, in the exponential graph, the x-axis was the horizontal asymptote. In a log graph, the y-axis is the horizontal asymptote. We sketch that in. And there's our graph. Now, it didn't ask, but let's just throw in a little bit of extra practice. Domain are y values. Domain are x values. Start at 0 and go to infinity, not including 0. Range, y values, negative to positive infinity. I want an x-intercept. That would be 1, 0. And then our asymptote would be the y-axis, which is x is 0. And there's the end of section 4.3.